Okay, today we're going to talk about how to identify the amplitude and the period, all right, of a cosine and sine graph. Now, first off, amplitude. Now, if you recall, amplitude is the distance, all right, from the midline of a sine or cosine periodic function to the max or min of the function. Okay, so when you have this, you have to think about, okay, what is changing when you're talking about the distance from the midline to this? So if I graph the sine function, let's just say I do sine. So we'll say here, we'll have right there. All right, so this is my sine function. Each one is going to be pi over 2 units. All right, and let's start 0 right there. And so we have this one, boom. All right, and we have that right there. So it goes, and there's pi, and then we go right there, and boom, like that. Okay, so here is my sine function. Now, if you have the sine function, we have an equation of sine of x. Now, the question is, how do you make it, if you want to change the amplitude, the distance from this point to this point, what do you do? Well, really, we are doing a vertical stretch. That means we're stretching, we're making it louder. Okay, I always think of sine functions as like loudness. So right now, if I want to make it really loud or a little higher, that means I want to multiply this by an a value. And that's what we have right there. We're going to multiply by an a value. So whatever the value in front of sine, that's the multiplier, and that will change it a units, okay? So the amplitude is actually the absolute value of a. So for example, if I put in, all right, y equaling 3 sine of x, what would happen? Well, that right there would take all my values, and I would multiply all the y values by 3. So instead of being, well, 0 would be still 0, but it'd still be at 1, it'd be 1, 2, 3, and I would have it up here. This would stay at 0, but this would be 1, 2, 3, negative 3 down here. That would be 0. So what I did was, as I stretched it vertically, I made it much larger vertically, and therefore making it louder. If I would go like this, I would say, well, therefore my amplitude, okay, is the absolute value of 3, which is just 3. We can also take this and I can make it halvesies, all right? So if I want to make it smaller, I could just take that and multiply by half. So if I did by half, that means all my values are 1/2 as big. So let's get a different one. There we go. All right. So if I would have this, it would just be at 1/2. That'd be 0. It'd be negative 1/2. That'd be 0. So it'd be just smaller. The periods stay the same. It's just it's a little bit softer. All right. A little bit not as high. All right. And we say the amplitude would be the absolute value of 1/2, which would be 1/2 right there. Okay. And so what we have then is we have an amplitude. So a, whatever the multiplier of sine, or you could also say that to cosine as well. All right. So y equals a times cosine of x. Whatever that coefficient next to sine and cosine, that will give you the amplitude of the graph. Okay. Well, period, on the other hand, period is really how long it takes to repeat, correct? So it's the length or the time for the function to repeat. And so when we talk about sine and cosine, we know the original period is always equal to 2 pi. That's for sine and the cosine function. All right, we talked about it in previous videos. Now, the thing is that I always think about this is that when we have our values, we have a sine. Well, how do you make the period so it would be smaller or bigger? Well, I think about frequency. Now, you might not know much about frequency, but when you think about frequency is how many times something will oscillate during a period of time. Okay, so if you want to increase the frequency within a graph, well, normally we have 2 pi. Well, if you want to increase the frequency, we're actually going to take and we're going to multiply the x by a value. And so what we have right here is that this frequency is actually making it larger. So that we're going to make sure if I had a 2 here, so if I had y equals a sine of 2x, what's happening is my frequency is going to be twice as big. So that means that the repeat will be twice along this interval, okay? So from 0 to 2 pi, we will repeat sine twice. So that's what it's saying here. However, if it repeats twice, that means the period would have to be half as big. So frequency is actually going to be, all right, b, all right, over 2a, or 2 pi in this case. So that's what frequency is. It's b over 2a, whatever that coefficient is. However, so in that case would be 2 over 2 pi, which would be 1 over pi. That would be the frequency. However, the period, if we took this and we made sine, so if it go from 0 to pi or 2 pi, that means sine is repeating twice on here. So what that means is that right here, instead of being, I'll just go right in the middle. So instead of being the halfway point at pi, actually that means it would have to go through a whole entire cycle once, one whole pi. And then it would go over again like this, because the frequency would be 2. There would be 2 cycles of sine within this interval of normally of being 2 pi. So actually, what is the period then? Well, the period actually became smaller. The time it took actually became smaller. So 1 repetition. So the period, how does it change? Well, the period then is in, even though the frequency is, all right, twice as big, the period actually is twice as, or 1/2 of it. So that's why when you want to find period, you do the inverse of frequency and you divide by b. So the period in this case is going to equal, all right, 2 pi divided by 2, which would equal pi. And we can see that 1 whole pi, all right, is now the period of this transformed sine function. Okay, and that's what we have there. And this would be a, and this would be negative a for our amplitude, whatever you want to have there. So this same thing occurs when you have cosine. All right, so if I had the cosine graph, I would say y equals a cosine of, let's just say, let's go over here, I say 1/2 of x. Well, what does that mean when I go 1/2? Well, the frequency is going to be half as long. All right, so that means that instead of being 2 pi, all right, it's actually going to be, all right, it's going to take longer, all right, to actually do that. Okay, so we would have 1/2 divided by 2 pi, all right, which actually would equal 1 over 4 pi. 4 pi. Well, what does that mean? Well, that means that because we are half, it takes, all right, it's actually, the frequency is half as big. Well, that means that it's going to be twice, the period's going to be twice as large. Because in order to achieve this, and we have this run right here, I'm just going to draw it out. All right, so in here, going to A, okay, so right there, we would have, okay, at pi over 2 pi, we would actually be at our 1/2 waypoint, okay? And so if we have this right here, I'm probably going to write this out again, okay? And so it's going to be twice as big. And so what we have there is going to be, all right, right here at 4 pi, okay? So we have pi, all right, it'd be 2 pi, and then 3 pi. And so we go boom, 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 and boom, all right? And we'd see that this would be twice as big. So each one is pi instead of being pi over 2, because we're lengthening this. All right, and why is that? Because in order to find this new period, the period is the inverse, all right, reciprocal actually, of the frequency. So it would be 2 pi over 1/2, which would then give me 4 pi. So period is related to what I call the frequency, all right? And the b value tells us what that frequency will be. And so we look at b, all right, which then will tell us our period, because it's the inverse of whatever the frequency would have to be, right? All right, and that will be for sine and for cosine. Oops, that's sine again. We'll go cosine. Well, let's do some problems just to help you figure it out. So right here, here's an explanation of sine and cosine. So let's go through some quick problems. So if I want to find the period and amplitude of each one of these functions, so cosine. Well, the amplitude we know is going to be the absolute value of a, so amplitude is going to equal absolute value of a. In this case, is going to be 2. So it's going to be twice as big. So the 2 and 2 for the max and min. The period, well, we see the frequency is going to be 3 times as big. So that means the period is the inverse of that. So we're going to have each time it's going to repeat is going to be 2/3 of a pi. All right, 2/3 of pi. Because period is always 2 pi divided by b, all right, for sine and cosine. And our b value happens to be 3. All right, amplitude. Here's my a, and so my amplitude is going to be the absolute value of that. And so we have an amplitude of 3/2. So a little bit bigger than 1. Our period is going to be, once again, 2 pi divided by b. We see that our frequency is going to be pi divided by 2 times bigger. All right. However, our period, if it's going to be bigger than that, then it's going to be the inverse of that. So we're going to take 2 pi divided by pi divided by 2. And that's going to give us 2 pi times 2 over pi, which is then going to give us 4. So our period is 4. We can look at sine over here. This is our a value. This is our b value. So amplitude, once again, is the absolute value of a, which will equal 1/3. So it's 1/3 as large for the max and the min. Our period is going to be, once again, 2 pi divided by b is our period. All right, the inverse of frequency. And so even though it's going to be periodic for 8 whole times from 0 to 2 pi, all right, normally, well, then what is the one period? Well, if you take 2 pi divided by 8, we realize it's going to be pi over 4. So every pi over 4, every 45 degrees, all right, sine is going to repeat. And it's going to be 1/3 as high. That's what we have. All right, so amplitude is, all right, how much from the distance from the line of oscillation or midline to the max and mins. All right, and finally, last one, you probably can figure this one out. Amplitude is going to be 5. 5 times as big from the top to the bottom. And sine, once again, the period is going to equal 2 pi divided by b, which is pi over 10. And so that would be 2 pi times 10 over pi, which will equal 20. All right. And so right there, we're going to have 20 is going to be our amplitude. So for that. Okay. And so that is how we find period and amplitude. Hope this helps you out. It's not too hard, but hopefully the frequency and understanding gives you a better understanding of how all this works. All right, good luck and God bless in the rest of your problems.